Lesson 94, Transversals. This lesson is a very rich vocabulary-based lesson. Some of the words you may already know, but some of them you may be learning for the first time during this lesson. So I just want to point out that it's very, very important that if a word is highlighted in a blue color or by bold information, that those vocabulary words are going to be very, very useful and important to you both in this lesson and in the future. Our new concept today is that a line that intersects two or more other lines is called a transversal. In the drawing on this page, you will notice that our transversal is actually R and that it is crossing S and T. In this particular drawing, S and T are not parallel. That's just to make the point that a transversal doesn't have to go through two parallel lines. However, in this lesson, we'll be focusing on the effects of a transversal intersecting two parallel lines. And just as a reminder, over here in our little concept box, in our math language, we're noting that parallel lines are lines in the same plane that do not intersect and are not always the same and are always the same distance apart. So again, S and T in this example are not parallel, but on our next show that these two lines that we're not now dealing with, M and N, are both indeed parallel lines. And it's for the ease of dealing with the lesson. But again, to emphasize that the transversal does not have to go through two parallel lines in order to be a transversal. So below, in our little diagram, we show parallel lines, M and N, are intersected by transversal P. Notice that it makes 8 angles altogether. And they're all numbered down there. In the figure, there are 4 obtuse angles. Hopefully you remember that obtuse is greater than 90 degrees, but less than 180. So our obtuse angles are all the odd numbered angles in this particular diagram. So in other words, number 1, number 3, number 5, and number 7 are our obtuse angles. And you'll notice the numbers are kind of like tucked inside the angle to make it where you know what they're pointing to. Our even-numbered angles, 2, 4, 6, and 8, are acute angles. And you'll remember that acute angles are less than 90 degrees. So there are, again, 4 obtuse and 4 acute angles in this diagram. Together, angles 1 and 2 form a straight line. These angles are called supplementary. That's a word that, again, you're going to want to pay attention to, the word supplementary here. Supplementary is when we have two angles that form a straight line. That means that their measures total 180 degrees. So if angle 1 up here just happened to be 110 degrees, then in order for 1 and 2 to be supplementary, angle number 2 would for sure be 70 degrees because our 110 and our 70 add up to our 180. You'll also notice that angle 2 and 3 are supplementary. So in other words, looking down here between 2 and 3, together they form their own straight line and again are supplementary. So that would mean that if 2 is 70, then again 3 must be a 110 to complete our supplement that way. And you can notice where this is going. That means 3 and 4 are also supplementary, which means that 4, again, completing our full little circle here, is again going to be 70 degrees. Now we'll notice some interesting things, that they form angle pairs. And we can describe some of these pairs. For example, we see that 1 and 5 end up being corresponding angles, and that means that we can carry the information from the top section down to the bottom, because in the same positions we see that number 1 and number 5, let's see if I can point to these, number 1 and number 5 are sort of partners or angle pairs. And because they're corresponding in their position, they have what we call a relative position. So 1 is to 5, as 2 is to 6, 4 is to 8, and 3 is to 7. The correspondence makes it where all the numbers from the top carry over to the bottom. So we can see that if number 1 is 110 degrees, then number 5 will also be 110. Here we have the same diagram again, where P is again the transversal, and it's crossing M and N, and we have our 4 acute and 4 obtuse angles, and we have our corresponding angles. And we're going to try and carry some of the information that we learned on the last diagram over now. So which angle corresponds to angle 2? So we had to find angle 2 up here. We have to learn how to read our diagram. There's our angle 2. And we need, when they say correspond, it's going to be down on the other line. So that's a group 1, 2, 3, and 4. And then the group below is 5, 6, 7, 8. And we have to say which one corresponds to number 2. And we can see here that number 2 is in the upper right-hand corner. So we want to go down to the other set, 5, 6, 7, and 8. And we want to see which one's in the upper right-hand corner in relationship there. And we see that that's 6. So we say that angle 6 corresponds to angle 2. Now, which angle corresponds to angle 7? Now we're starting in our lower right-hand side, and we want to say which one up above corresponds. And again, it's below line N, so the one up here below line M on the right-hand side is 3. So we would say that angle 3 corresponds to angle 7. Since lines M and N are parallel and line P intersects line M at the same angle as it intersects line N, the corresponding angles are what we call congruent. Congruent is a geometry term, and it means that they sort of match up, okay? Thus, if we know that angle number 1 measures 110, we can also firmly conclude that angle number 5 also measures 110 because they're congruent, because they correspond. So again, lots of vocabulary words. The angles between the parallel lines number 3, 4, 5, and 6 in the figure on this page, it says previous page, but it's on, I put it on our diagram here again, are interior angles. Ooh, we better pay attention to that one. 3, 4, 5, and 6. So these ones in the middle here, 3, 4, 5, and 6, are labeled as interior angles. And if we know our vocabulary words carrying over from other English words, that kind of makes sense. They're on the inside. And the exterior angles out here would be 1, 2, 6, and 7. So we can say that the interior angles, angles 3 and 5, are on opposite sides. So that makes them alternate interior angles. So again, a lot of this is vocabulary heavy. So we say that 3 and 5 alternate because they're on opposite sides of P, right? And they're interior because they're in between M and N. Now we can name another pair of alternate interior angles. If we can say that 5 and 3 are alternate, then 4 and 6 are the other alternate interior angles. Alternate interior angles are also congruent if the lines intersected by the transversal are parallel. So again, this is only in the case of parallel lines, but if they're parallel, we can conclude that the transversal is going to cut them the same way. Okay? So the alternate interior angles are congruent if the lines are parallel. So if 5 up here measures 110, then we can say that 3 is also 110. Because remember, 5 corresponded to 7, and 1 to 3, and 5 to 1, and 7 to 3. So it's like they're all related. All right? Again, like I said, this is like a giant puzzle. So angles not between the parallel lines are exterior angles. So again, 1 and 7 are exterior, outside of the box, so to speak. And we can say that angle 1 and angle 7, which are on opposite sides of the transversal, are alternate exterior angles. And again, they're going to be congruent. They're going to, if we know that one of them is 110, we'll know the other one is. Now the reason this is so important is it is like a puzzle. If I know angle number 1, I end up knowing almost every other angle in this puzzle because it's either going to supplement something else or correspond to something else or be congruent to something else. That's how we start filling in the missing pieces. So when we named another pair of alternate, oh, did we name another pair? No. We need to name another pair of alternate exterior angles. And that would be, if we had 1 and 7, it would be 8 and 2 would be the other pair of alternate exterior angles. So if the measure of angle 1 is 110 up here, then 7 is 110. Okay. And if these are the supplements and they're 70, then they're both 70. So there's more than one reason why we can say the measure. We can say the measure because of it's a supplement, we can say the measure is because it's correspondent, or we can say the measure is because it's congruent. All of them are valid ways to find the missing measures.